We've got a submission here from Gooch. He is submitting a log from a Kermit 170 frame with 1806-2300 motors and 4-inch props on 4S. Should be very interesting. I don't think we've had very many submissions from copters this small with the little 4-inch props and 4S power. So it should be very interesting. And just asking for some general fine-tuning advice. So let's take a look. Let's dive in. We'll take a look and see what we see. I'm going to start by taking just a very quick look at the gyros, just to make sure everything is suitable there. I'm going to zoom out to 10% and see what we got. I am definitely seeing some oscillations here. A lot of oscillations on yaw. You know, if there's high frequency oscillations, the line kind of just gets thick. But here, you can almost see the jaggedness of the line, like right here. This is not yaw, but like right here. This is looking more to me like lower frequency oscillations that might be the result of your tune, like excess P gain, because instead of being such a high frequency that they sort of blend together to become one fat line, we're actually seeing the individual up downs, which are a lower frequency, and that's more consistent with a P-term tuning issue. So I think that it's likely, like if we look right here, your line right here, your gyro line is very thin, nice and thin. And likewise here, your pitch is very thin. I think that overall your amount of vibration or noise is very low. And that's consistent with 4-inch props. The smaller the prop, the higher the frequency the oscillations are going to be, and the weaker the oscillations are going to be, just because less mass is swinging around, right? So I think it's unlikely that you have excess vibrations, but rather that you have a tuning issue. And I think this is a really nice thing to point out. P-term oscillations are usually in a certain frequency range. I'm not going to try and off the cuff tell you what, like a number, but it's a lower frequency than something like a prop being out of balance, which is going to be more in the range. The fundamental is going to tend to be in the range of around 350 to 400 hertz for a typical sort of 5-inch or 6-inch prop mini quad, and then it's going to have harmonics down around 100 to 150, maybe a little higher hertz. It all sort of depends. Whereas P-term oscillations, they're more in the range of, now I'm going to give you a number after all. I would say P-term oscillations are more in the range of like 20 hertz, something like that, maybe. So there's a pretty big difference there. These lower frequency oscillations that I think we're seeing here that are manifesting as individual jagged lines instead of one sort of fatter line, I think are a tuning issue. So let's take a look first at yaw, because yaw really seems to be having the biggest issue here. And here, as we look at yaw, we can see immediately that there's a tuning issue here. The P term is oscillating like crazy. We see these regular, sharp oscillations. Right here is just a very stereotypical example of an overtuned P term. Notice that as we go right here, we start to lose this regular S-shaped sine wave shape, and it starts to sort of break up a little bit. This right here might be an example of an on-the-edge P term. Active, not quite becoming overactive yet, right? But then we get to like right here, and it starts to look more like a sine wave. And then right here, oh, this is a way overactive P term right here. This is just a very stereotypical case of what that looks like. So you know, get a good look at it. Right here, again, P term going crazy. Really going crazy here. So the yaw P term here is definitely too high. Definitely, no question. And I think this is a very interesting thing to point out because notice we say it has no tuning issues as such that he complains of. And this just shows how much of a variance there can be between what a pilot perceives as, yeah, it's flying pretty good, I like it, and what's going on underneath. I think it's likely that a person like me who's just a complete nitpick about tuning would hear these oscillations in flight and maybe even see them in the video, but probably hear them first. That's usually where I find P-term oscillations first, is by listening to the audio of the motors, okay? But it's quite likely that someone who wasn't a total nitpick wouldn't even notice it and would think the copter was flying very well. And so that's why I give the guideline of if you find a point where you notice oscillations, then set your P gain at like 65% of that. And people are like, whoa, hey, why don't you just back it down just barely until the oscillations go away? And I'm like, because the oscillations are still there. You don't hear them and you don't see them, but they're still there. And this is an example of that. And so then the question we could ask is, well, if it's flying okay and the pilot's happy, should we change it? And the answer to that, well, obviously it's your copter. You could do whatever you like with it. You crash into the ground if you want to. But ultimately, this is not helping your flight performance. This is not sharpening up. You're like, well, okay, I'm going to raise the P gains until it gets really nice and sharp on the edge. You know, you drive a car hard, the tires are going to squeal sometimes, right? If your tires aren't squealing, you're not driving it hard enough. And if you don't hear some oscillations, your copter isn't tuned sharp enough. Okay, I'm open to that argument, but this is way over the line. You're not just squealing the tires a little bit in the turns. It's shaking itself to bits here. This is too much. So way more P activity here than I would like to see. And I think the P gain on yaw definitely needs to come down. Let's take a look and see what it actually is. I've got your log here, which you helpfully provided. Thank you so much for that. It's going to be useful now. You are, where is it? P controller is lux float, so we're going to look at your float values. Your yaw P is 4.0. Okay, take that down to 2.0, I would say. 2.0 is probably too low, but take it down to 2.0 and take another look at the black box and see what it looks like and what it feels like. 2.0 may not be too low. It might be too low, but we'll take it down and look at it. This is way too high, though, way too high. I also noticed that your D gain on yaw is 10. And if you look at the D term here, it's actually really impressive how well behaved the D term is, given how flipping out the P term is. We don't see the D term is about half or less the magnitude of the P term, even when the P term is becoming very active. And the D term, it's just sort of following along. So your D gain is not too high. In fact, your D gain could probably come up to maybe 12 or 13 or maybe even 15 as a starting point. But your P term has to come down first and then take it from there. When you lower your P term, you'll probably find that your D term trace becomes even more docile and you'll want to raise it back up. But leave your D term where it is for now because you want to get your P term roughed in correctly before you start raising your D term. Yaw P definitely needs to come down. Okay, let's look at your other axes. All right, so now we're looking at pitch, and I know that I did see some jagged stuff that looked like overtuning in the gyro trace, but right now I'm just gone to a random section of the flight where you've got it at about mid-throttle, and nothing about this looks too bad to me. This looks pretty decent. We see the P term is active and working. It's moving around and doing its job. We don't see the P term flipping out at any point. No gratuitous signs of overtuning, right? This is good. Here we've got a flip, and we see the P term doing its thing. A little bit of oscillation during the flip, but I wouldn't worry about that too much if everything else looks okay. If we go, there's a section here where you go to full throttle and the P term becomes much more active. None of it starts to, maybe a little bit of motion here, but nothing that looks like those hard sine waves that we were seeing before. The P term is sort of coming on and backing off, going up and down, slower and faster as it needs to. None of those hard regular sine waves that are just clear signs of oscillation. Starting to get pretty active here, but yeah, you're at full throttle. Maybe that's okay. The main thing that stands out to me right now about your pitch axis is that the D term is pretty active. We're seeing a lot of, anytime the P term changes, like right here, whoop, the D term spikes, right? So we kind of want to see the D term having roughly the same shape as the P term, right? And sort of almost like they're following each other along like dance partners. And here we've got cases where, like here, for example, there's this little extra jaggy here that isn't really present in the D term or the P term, right? So it's starting to suggest to me that possibly, and here we see that the the D term has more magnitude than the P term, right? It's going taller than the P term in both directions. So it feels to me like possibly your D term may be a little overtuned. And that's really a matter of feel. It's relatively easy, I feel like, to judge the P term just by I look at your black box traces. I can tell you exactly what I think your P term. And my flight experience bears that out. That when I look at a black box trace and I say the P term is overtuned, and then I go fly the copter, I feel like it's over. I'm like, yeah, okay, I get it. The D term is a little bit more subjective and a little bit harder to judge just by looking at the traces. There are cases where the D term can look in black box like it's a little bit overtuned, but that copter flies really good and there's no signs of trouble and you stick with it. Let's just take a look here. Your pitch D is 20. I think I would consider dropping that down to, let's say, 17 and see if you still like how it flies or if you like how it flies any better. If you don't, it's going to be a real subtle change, but the trace, it may handle prop wash oscillation a little better and handle more extreme flight conditions with a little less oscillation. Your P term, though, your P term looks like it's maybe right on the edge of being overtuned, but not quite there. And so I think if your D term was happy, then your P term would also be happy. On the other hand, you may find that when you reduce your D term, your P term oscillations get worse. It may be that the D term is helping hold the P term back, and you may need to drop. Oh, see, now here, this is an oscillation for sure. What are you doing here? I don't know why you're oscillating here. It's really hard oscillation. Way too much something. Way too much something. Yeah, see how the P term is barely moving here, but the D term is all over the place? That's saying to me that your D gain is too high. I don't know why you're oscillating here. It doesn't really look, maybe a prop wash situation. It doesn't really look like you're doing much. Maybe knock the P term down just a smidge. Let's see, 1.5. Maybe take it down to 1.4 or 1.3, possibly. It's going to be a little hard to find the balance here between D and P and get that right. Okay, but feel that out and take a look at the traces. And of course, always go by the pilot's feel as well. Definitely, I think the D needs to come down. Maybe the P could stay where it is. Hard to know how the P is going to react to the new lower D. So if the P is on the edge right now and you lower the D, P may then be over the edge and be oscillating too much. Okay? Let's take a quick look at roll next. What am I going to say? Pause the video if you want to. What am I going to say? Oh my goodness. So much oscillation, right? I just play the track back from what I said on yaw. Now this is interesting. This is actually interesting. Oh, I take it back. I take it back. Oh, it's just that one spot. I don't know what you were doing in that one spot where it flipped out. Yeah, no, no, no. I stand by my conclusion. This is too much activity in my opinion, and P gain is too high here. I was about to when I was looking at this section of the trace, I see that the P term is moving, right? But it's not flipping out yet. It's not oscillating hard. And the D term has a little bit of extra motion, but overall the D term is sort of roughly following the P term. They look okay. But if we keep going, we get to here's a hard oscillation for sure, right? P term right there. Hard oscillation for sure. Here, hard P-term oscillation for sure. Here, these shapes that I don't know if I can describe to you what the difference is, but if you look right here at what the P-term is doing, boom, right here. Hard oscillation for sure. And look at the gyro going back and forth. You definitely can see this in the camera. It's not just an invisible thing. If you compare these things to the other things I've shown you, like here where it's moving around but it's not oscillating. I feel like, and here it's just doing its thing, but you're at relatively low throttle, and that's why. Okay, so yeah, definitely P gain needs to come down on roll as well. Probably a pretty fair chunk. Let's see what it's at. Yeah, so here you've got your pitch and your roll at 1.5. They're both the same. Since your weight distribution is probably not perfectly symmetrical, they probably shouldn't be the same. So I think I would consider taking roll down to 1.2, maybe 1.1, and pitch maybe knock it down to 1.4. Just take a tiny bit off of pitch. And that's all my time. So I hope that's been helpful, and happy flying.